Good day, everyone. I am Cari Justin Estrellado from Quezon Province. I'd like to begin by expressing my appreciation to the organizers and committee of the first International Research Conference on Interdisciplinary Perspectives for inviting me to speak today. It's actually a great honor to be part of this inaugural event. I would also like to acknowledge the presence of our presenters who will be joining us in parallel sessions later on. Now, of course, I look forward uh, sh- to sharing my insights on mistakes-based learning and snippet of systems thinking. This is the rundown of my presentation. Certainly, due to the time constraint, I would be synthesizing some of information to make it more digestible. All right, shall we start? Okay, we are all in this together. I'm speaking, you're listening, someone does the technicalities, someone is even preparing for the presentations later on while we are here and whatsoever right now. Well, it boils down that we are all interconnected, even if we don't always notice it. It doesn't happen by surprise, of course. Systems, of course, both inside and outside of us, create invisible and visible links that connect us across time and distance. And in connection with that, now, this bridge the term system, wherein something more than a collection of its parts. Systems thinking involves understanding complex issues by viewing them as interconnected systems rather than isolated components. Well, it actually requires looking at the big picture and recognizing how elements interact and influence each other. Systems consist of elements that work together as a whole, like, of course, the human body, forests, and economies. Well, these systems can exist within larger systems, such as a city comprising smaller systems like local government and businesses and the like. All right, now we have here in this presentation when used in the context of social change, for example, like many people in the Philippines, in our country, assume that system is referring to either the government system, systems of political governance, or socio-economic systems. Well, yes, these are examples of systems, but systems thinking, our topic, can also be applied to different systems, both big or small. For example, you could see here uh, family as a system, as what we can see here, questions like uh, who are considered to be the members of your family. That could be the elements. And what else? What are the different roles that each member plays? And what is the relationship like between the family members? So we're dealing with relationships here. Another is what rules are followed in your family? What resulting patterns of behavior can you see? And those actually the results. Okay. So the same can be applied to our organization or to your organization or company. What are the different teams and departments and how do they interact and affect each other? What are the rules and social norms within your organization? And what are the trends and patterns in terms of your organization's performance or outputs? Systems thinking in practice encourages us to explore interrelationships. When we talk about that, it's all about context and connections, perspectives. When dealing with perspectives, we are dealing with each actor has their own, of course, unique perception of the situation and boundaries, of course, and which is it's all about agreeing on the scope, the scale, and what might constitute an improvement. of course, they all require shifting to a new way of thinking. Well, as you can see here, systems thinking, interconnections, elements, function, or purpose, depending on what studies you are dealing with. A system must consist of the three kinds of things. We have here elements, interconnections, and a function or purpose. And if we could able to synthesize about systems thinking here, as I described, oftentimes it involves moving from observing events or data, identifying patterns of behavior over time, and underlying structures that drove those events and patterns. Now, here, when they think about systems thinking, of course, it's all about systems mapping. It's all about visualizations. Yes, that is one of the key tools for systems thinkers. Instead of reacting to a situation based only on what we can see, systems thinking tells us to dig deeper. And here are some ways like mapping. I think some of these are not new at all. From analog cluster mapping to complex digital feedback analysis, the fundamental principles and practices of systems mapping are actually universal. Now, we always need to remind ourselves that the maps we create are, snapshots of the system at a certain time, and it could be based on our experience and perspective. Now, of course, things will change, and we will need to revisit and rethink our maps and visualizations or concepts here. So don't get too hung up on creating the perfect map because these maps are only supposed to help us discover insights and visualize the bigger picture. All right. So they are not the goal itself when it comes to systems thinking. Okay. So, all right. Before we dig more about systems thinking and about later on, mistake based. I'm inviting I'm inviting everyone actually for a quick three-item assessment. This is actually only a true or false, anchoring the lenses of systems of thinking. You may actually put your answer in the chat box for quick checking. All right? So here it goes. Okay, to start with item number one, improving individual system components can lead overall system improvement. That is our first statement. You may start putting your answer on the chat box. Okay, what could it be? Okay, the answer is, of course, it's false. Well, a system is more than the sum of its parts, like what I said a while ago. The interactions and relationships between components are crucial to the system's overall performance. Then it can ripple to the entire systems. Okay, that's one of the premises of systems thinking. Next item. Disciplines are taken by science to represent different parts of the reality we experience. Type in number two. Answer still false. First, disciplines do not constitute different parts of reality. They are. They are different aspects of reality, different points of view. Any parts of reality can be viewed from any aspects, but the whole can be understood only by viewing it from all the perspectives simultaneously. Okay. And for the last item, we have here the best thing that can be done to a problem is to solve it. What could it be? For our last item. Okay, the answer is false. The best thing that can be done to a problem is to see the connections from different problems, then dissolve it. While solving a problem is often necessary, eliminating it can provide a more effective and long lasting solution, especially when dealing with persistent or recurring issues. All right? I hope you got it right. All right. Now, thank you for answering. Now, we all have problems, right? Of course, we do. Now, we know that we are all living in a world full of systems inside us and around us, where everything and everyone is interconnected. Well, some systems work well, while other systems cause problems that can lead to suffering or inequality. And with this, why do we need systems thinking? Because, of course, we have all problems, right? And here are the following types of problems that we face. We can, of course, hierarchically categorize them into simple, complicated, and complex. Now, for simple problems are easy to understand and have just a few factors involved which are mostly within our control. For complicated problem, usually requires the involvement of experts to find a solution. Well, you can easily define what the problem is and what are the many parts affecting the problem. You can apply best practices based on what has worked before. And for the complex problem, the context of the problem is always changing. It's actually very hard to predict what will happen because the cause and effect relationship, the cause and effect relationships are not actually clear. And solving one part of the problem can cause unintended consequences in another. So what has worked before may not work this time. Of course, experts can be helpful, but their involvement doesn't guarantee success. So here are the following problems uh, that we could identifying the level of problems for systems thinking. Okay. Now, when you begin to address an issue, avoid assigning blame, which is a common place for teams to start a discussion. Instead, uh, we could ask, what is it about this problem that we don't understand? In addition, to get the full story of it, we could emphasize the iceberg framework. So I'll show you later on. So the group can describe the problem from all three angles. Events could be events, patterns, and structure. And finally, we could assume that everyone has the same picture of the past or knows the same information. Therefore important to get different perspectives in order to make sure that all viewpoints are represented and that solutions are accepted by the people. And of course, when investigating a problem, involve people from various departments or functional areas as we call on, and you may be surprised to learn how different their mental models are from yours. Okay. And of course, yes, take note of this, that what is it about this problem that we don't understand? Actually, the gist of this slide. Now, here it is. A while ago, yes, uh, I mentioned about the iceberg framework. So this actually could be one of the map that you or framework that you could visualize when, of course, people or organization are able to look at things from a bigger picture, systems view rather. It allows them to make higher quality decisions and minimizes unintended consequences. And one of the most significant contributions to building this capacity is, of course, a systems of thinking. Okay. So now we have here two terms. So both refer to doing something wrong, right? However, mistake is less formal here, and it is insignificant compared to an error, depending on the context, right? A mistake, a mistake is a human action or decision that is not intended or that deviates from the outcome that is expected or good. Mistakes can be made due to the lack of knowledge, carelessness, or poor judgment. For example, a student who writes the wrong answer on a test has made a mistake, whereas error, on the other hand, is a deviation from accuracy or correctness. I label it as a deviation from a system. When mistakes are made, the implication is that there was no system or set of rules in place to guide the decision or action. Generally, when a mistake is made, we want to avoid future instances by creating rules, guides, training, or something to help us avoid the mistake in the future. So with a system put in place, the same incorrect action in the future would be labeled as an error. Okay? So certainly errors are all around us, but when it comes to mistakes, well, mistakes are errors in the planning of an action. All right? Mistakes are errors in the planning of an action. Learning rarely happens without mistakes. Okay? Since it is part of human action or decision that is unintentional or, somewhat deviation. Instead of looking at a mistake as some horrible thing that should be hidden, we should leverage the mistake as learning opportunity. And of course, there it is, failure may also be inherently more difficult to circumscribe than mistake, because failure is a broader term that implies a more significant setback or inability to achieve a desired outcome. It often involves multiple mistakes or systemic issues, rather. Systemic issues, of course, failure can be disheartening, but you know, can be part of innovation and change that could catalyze innovation and change. Whereas mistakes are learning experiences, while failures here can be more devastating and require a more substantial recovery effort when viewed holistically here. And yes, of course, due to time constraint, there is much more to discuss about systems thinking, but I'll just give you the overview of it. Now, in micro stance, sorry, mistakes are painful when they happen. But years later, this collection of mistakes called experience leads us to success. Well, if it's good, it's going to be wonderful. If it's bad, it's going to be an experience. Well, of course, events were largely beyond our control, and while we can't always prevent mistakes, like what I did, even errors or failures to happen, we can control our response to them. Okay, so this is the snippet. Mistakes based learning operates at a micro level, focusing on the individual or group errors as opportunities for growth. Systems thinking, on the other hand, adopts a macro level perspective, examining how interconnected elements interact within a larger system. So, Covadis, where could it take us or lead us? Since we know that systems constantly change and complex problems will evolve, our systems changing work is often, never truly finished. And yes, it can help us to ask right questions. Asking right questions might sound like just a simple thing, but it's actually one of the most important skills in life. Whether you're a student, an employee, a parent, they will also always lead us to the information and answers we need to make informed decisions. Okay? So, yeah, why reconfigure the systems? Why do we have to? Okay? Well, reconfiguring systems thinking demands a shift from isolated optimization to holistic improvement. We must challenge assumptions here. We are prone to change. We are prone to change, and I mean, we don't, we must not perpetuate the status quo. Because when it comes to systems thinking and its applications, it can reveal unintended consequences, such as environmental impacts of, you know, changes or social changes from different factors or facets. It encourages finding solutions, of course, from those changes. And of course, aiming systems thinking, of course, is aiming from longer term for sustainable and effective outcomes. Now, the intersection of mistake-based learning and systems thinking, the unique connection between these two main topics lies in their shared focus on understanding and improving complex relationships. Systems thinking emphasizes the interconnectedness, whereas mistake based learning highlights the importance of examining errors as a system wide issue rather than the isolated incidents. Okay. Now, to wrap my presentation here, therefore, systems thinking is most effective when it's used to look at a problem in a new way, not to advocate a predetermined solution. Okay. So that's it. Here are my references. Okay. Thank you. So before the Q&A session, I want to leave this message. We don't learn from experience. We learn from Reflecting on Experience by John Dewey. That ends my part. Thank you for listening.